Yeah.
Oh yeah, it is.
Remember that I'm showing you which ones can be done in Desmos. If it can be done in Desmos, 3 can. I don't remember 4 can. 5 also can.
Yeah, why
So with this one, I can do this a couple different ways. Can I borrow your shirt?
Sorry.
You can either put in as a capital letter X equals -3. So I probably should do this first, but if you put in the equation, capitalize all the x's, and then put in x equals -3, it will give you the answer. Or you could put -3 in using parentheses. So -3, okay. Squared. Make sure the squared is outside of the parentheses. Plus 2 times -3. So you can do it either way, either using this, or you could use a different variable.
The answer is 3.
The answer is 3. Or you could use a different variable. You can't use lowercase x. So capital X, and then make it a slider. Put in the original, and it'll give you the answer. Or you can put the number into parentheses as you normally would evaluate. If you use either of these, you could just say use Desmos. Questions on that one? Okay. Number 4 is like what we did yesterday. Put in the points.
Can you tell us again how to do it up on
So the ones that we can do in Desmos, I'm no longer doing. So for the slope, if you were to put both of these in, these fall on the same line. So if I were to count the rise, there is none. There is a run though. So the slope of this would be 0 over 7, which would just be 0.
Do we need to use this like without Desmos? We need to do it without Desmos.
To do it without Desmos, we need to do it with Desmos. So what are you talking about?
Like on the test.
On the SOL?
Oh, it's not like. This guy. Yo, never mind, guys.
For number 5, since we're looking for the line that goes through this slope and this point, you can type in this slope and this point in our y equals mx plus b. So I'll type y equals mx plus b first. It doesn't really matter which one you put first, but add all my sliders. Change my slope to -2/3. And then I'm going to put my point -2,4. And I'm going to move B either by pressing the play or moving the slider itself until it goes through that point. It's some decimal, 2.7. So to graph that, you could use the point that was given and then use your slope and just keep doing that. points are not necessary. That one you didn't really need to use decimals, so I was just showing you what you could do on decimals to see what it looks like. But because you're given the slope and the point, to start at the point, use your slope and keep going. Questions on that one? Alright. Few things, look at your course calendar. Take note of all of the important dates. Your quiz is going to be the 16th, which is next week. Your test is going to be after President's Day on the 23rd. Flex Day after that. This unit is going to move very fast. The rest of the units that we do are going to move very fast. We're only going to take 2 more tests before the SOL, and then the rest of the tests will be after that. But we'll talk more about that later. If you use your course calendar often, I would write down the beginning of each week when your SOL things are due. So remember that next Monday, on the 12th, the SOL A1 is due. And then on next Monday, I will tell you what the next set is. Take note of your Delta math. There are 2 due this week, 1 that we're going to talk about today and probably finish tomorrow. And then the other one we're going to talk about tomorrow. And then there are multiples that are due next week. Questions about any of that? So on your notes, this unit is on, I don't have this one up. Inequalities. Some of this stuff you will know, some of it you won't, and it'll be new to you. At the top, it says use and that's open circle. You gotta write open circle while I'm getting this to load. Or less than or greater than signs. And then use a closed circle for less than or equal to or greater than or equal to signs. So in these next examples, we're given some things that maybe they were solved already and we just have to graph them on the number line. So for number 1, we would start at 3. Would this be open or closed based on the symbol? Open, because it's strictly less than. So we would put an open circle at 3, and then we would draw an arrow. Would this go to the left or to the right? To the left. It would be everything less than 3. So this shows all of your solutions. All numbers that are less than 3 could make this true. If you're not sure, you could pick a number, put it in for x. If it's true, then that's the direction. If it's not, then it goes the other way. For number 3, we would start at 7. Would that be open or closed? Closed. Going to the left or to the right? To the right. To the right. Everything greater than or equal to 7. Most of the time, the direction the arrow is pointing is the direction you're going to go. But sometimes that is not the case. I'll show you later when that's not the case. Then in 5 through 8, they switched it. Now we have the graph and we have to write the inequality. So for number 6, actually, let's do 7 instead. It starts at 0. We know it's closed, so it has to be less than or equal to or greater than or equal to. Which one would that be?
X is less than or equal to 0.
Less than or equal to, because it's going to the left. It's closed, so it has to be filled in. What about number 8? It starts at -3. It's open, so it has to be either strictly less than or strictly greater than.
-3 is less than x.
So are these numbers smaller than -3?
Smaller than.
It's greater than, yes. Questions on how we graph or write the inequalities so far?
But does it matter if you are like -3 is less than x or x is greater than x?
So if you write it the other way. So if you were to write it the other way, you have to write it in the same kind of order. Whichever direction the symbol is pointing to or away from the x, it has to work the same way. So if you want to flip the whole thing, you could do that. It just has to be pointing away from the x. So this would be a case where it's not necessarily going in the same direction as the arrow, and you would have to be careful with that. Right? The main rule for solving inequalities, you must flip the inequality symbol when you multiply or divide by a negative number. I'm going to give you an example, a couple of examples of what that might look like. So if I had something like -4x, I'm making this up, is greater than 4. And I divided both sides to solve this by -4. The sign is going to change directions. But if I had something where whatever was on the opposite side I was dividing, so like 4x is greater than -4, and I divided both sides by 4, the sign would not change.
So it always has phasing with x.
Whatever
Well,
is
whatever
being divided with x. If that part is a negative, then you flip the sign. But if you're dividing and the number is already negative, you don't change the sign. The nice thing about solving inequalities is it's the same as solving equations. Just we have to keep that rule in mind. So then how would we solve number 9? Subtract 2 on both sides. And then divide both sides by 3. So x, would the sign change? No. It's less than -2. You have a blank number line. You can fill out whatever numbers you want. I like to put mine in the middle and then go out from there. You don't have to do that. Just fill out the graph. And then would that be open or closed? Open, going to the left or to the right? To the left. Everything less than -2. And that's how we solve an inequality. Questions there? Okay, let's try 6. How would we solve that?
-2 to both sides.
We have x over 6 is greater than -3. And then
Multiply 6.
multiply both sides by 6. If this 6 was negative, then I would be changing the sign, but because it's not, the sign's going to stay the same. And then again, fill up your graph, put whatever numbers you want there. And your numbers. Would that be open or closed? Open. Going to the left or to the right?
To the right.
To the right. Everything greater than -18. Again, if you're not sure, pick a number, put it in for x, see is it make it true or not. So like negative 24 is not greater than negative 18, but negative 12 is greater than negative 18. When you finish that, go on to the next page. So not only do we have to solve our inequalities and graph them on the number line, but we also have to talk about interval notation. So our interval notation is basically another way to write our x is greater than 1, that part of the inequality. But when we write it, we're going to be using parentheses and brackets. When we use parentheses, that means not included, or you would be using an open circle. So if you use an open circle, you'd be using a parenthesis. If you were using a closed circle to mean it's included, you'd be using a square bracket. And then I'm going to explain what this part means in a minute, but if it goes to negative or positive infinity, we always use parentheses. So this part can be done at the end or in between. We'll solve another one, see how much time we have, and then do this problem. And this may be the last one. We may have time to do one more. I'm not sure. So with this one, you could either distribute or divide everything by 4, since this goes into 4. This 24 goes in 4 goes into 24. Which would we rather? Distribute or divide? If you want to divide, go for it. You would be dividing this and this. But if you distribute, we have 4x plus 12 is greater than negative 24. And how would we solve that? Subtract 12. Divide both sides by 4. Is the sign going to change? No. So graph it just like normal. Fill up your graph. Would that be open or closed? Open. Going to the left or to the right? To the right. Everything greater than negative 9. Now, for the interval notation, this is how we write this. We're looking at this left to right. Wherever this starts, so this one starts at negative 9, we look at, is it a number or is it infinity or negative infinity? If it's a circle, we look at whether it's open or closed. If it's open, we use a parenthesis. And then put that number, so parenthesis negative 9. And then where would this end if it kept going to the right? Infinity. It wouldn't. It would keep going towards infinity. So you would write infinity, and then infinity always use parentheses.
So you'll always bring infinity?
Yes. Or negative infinity. It depends on which way the arrow is going. Questions on how we do the interval notation so far? Okay, let's do one more. For this one, go ahead and distribute. Combine your like terms. Add 6 to both sides. When we divide, is the sign going to change? Yes. So go ahead and graph that. Should be open to the left. Now if we're looking at that interval notation, where would that start? Yes. That's not where it starts, it's where it ends. So if it keeps going left to right.
Oh, infinity?
Negative infinity. Yes, Sam. Positive 1 minus 2. So 1 minus 2. and then to -5, and then parentheses.
Why did we switch to
Because we're looking at it left to right.
What's
So,
L minus
left to right, it starts at -infinity and stops at -5. Shine, did you ask a question?
Yeah.
Any other questions right now?
Wait, how can we put infinity first this time?
So we're looking at it left to right. If we're looking at it all the way to the left, this is going to keep going to -infinity, and it's going to stop at -5.
Alright.
Okay. So we're going to finish this tomorrow, as well as the word problems that are attached to it. So hold on to this